Okay, we now move on to learning objective 2G, which is the speed time graph. Okay, we're looking at speed time graph. Just now we're looking at distance time graph, now looking at speed time graph. Okay, so we're supposed to be able to interpret from the shape of the speed time graph different types of motion, right? At rest, moving uniform speed acceleration, and non-uniform acceleration. Okay, so with a speed time graph, like the graph shown below, what are we looking at, right? So the axis tells us the speed, y-axis tells us the speed, and x-axis tells us the time. So when we're looking at the speed, when is it at rest? It's at rest when the speed is, so we're looking at speed time graph, I remember. So at rest means speed is 0, right? So when is it at rest here? Here is when the speed is 0, so I guess it starts at rest, right? It starts at rest, and the next time it's at rest is here, right? This region here is at rest, because it's when the speed is 0. Okay, so you have to be very clear of what the axis is, right, and what you're trying to read. So in this case, when you read a speed time graph, you're reading the speed directly off the axis. Okay, moving with uniform speed, what does that mean? Uniform speed means speed is constant, right? So constant speed, which means the speed doesn't change at some speed. So when in this graph, which part is constant speed? You can see that this part here is constant speed. What is the constant speed? It's the constant speed of 4 meters per second. Can you see? It's moving at constant speed of 4 meters per second. Right? So the speed doesn't change. Next, moving with uniform acceleration. So what does the gradient, so if the graph itself tells you the speed, what does the gradient of the speed time graph tell you? Oops. So the gradient of the speed time graph tells you the acceleration. Okay, yeah, because the gradient of the speed time graph is the rate of change of speed, and rate of change of speed is also known as acceleration. Okay, you can also take the units. How to find gradient is rise over run, right? So y-axis over x-axis, the units will give you meters per second divided by second. Meters per second divided by second will give you meter per second square. Meter per second square is the unit of acceleration. Okay, so these are different ways to make sure you know what you're doing. So when is it moving with uniform acceleration? Uniform acceleration means constant acceleration. So again, the question to ask yourself is the same as in the distance time graph questions. You ask yourself, how is the steepness changing? So can you see when you're trying to see acceleration, you're looking at the gradient, and the gradient is also, in colloquial terms, is simply the steepness. So if you want to ask how the acceleration is changing, you ask how is the gradient changing. If you ask how the gradient is changing, how the steepness is changing. So uniform acceleration means constant acceleration. You're looking for constant gradient. You're looking for constant gradient. So you're looking for constant steepness. Is there anywhere in this graph that's constant steepness? Other than moving at constant speed or at rest? Is there okay, so this is constant speed and at rest, but the acceleration is 0, right? So because the acceleration is 0 here because the gradient is 0, right? And here you have a constant steepness here, right? It is getting the steepness is the same as the speed is decreasing, right? So this is a uniform deceleration, right? It is getting, the speed is decreasing at a constant rate. Yeah. If you look at moving with non-uniform acceleration, is there anywhere that's moving with non-uniform acceleration? Right? You have this region here, which is getting less and less steep. Can you see if you're walking? It's from left to right. It's getting less and less steep. So if it's getting less and less steep, that means that, so for this region, less and less steep means the gradient is decreasing. If the gradient is decreasing, that means acceleration is decreasing. Another way of saying this is that the speed is, if you look at the speed, it's increasing, right? So the speed is increasing from 0 to 4. The speed is increasing at a decreasing rate. Okay, the speed is increasing at a decreasing rate because the acceleration is going down. The gradient is going down, it's getting less and less steep. Okay, but that's for explanation questions. Simply for MCQ, I just want to get idea that you can identify these things. So let's look at the question. Question 3, the diagram shows the speed time graph for the motion of a boy on a skateboard, which row describes his motion for each 5-second period. So we know that the 0 to 5 seconds is going to be less and less steep. So less and less steep means the acceleration is changing, so it's non-uniform acceleration. So you have these two. Okay, these are already out. Next, 5 to 10 seconds, is it at rest or is it constant speed? So what's the speed from 5 to 10 seconds? We talked about it earlier, it's 4, which means down here to here is constant speed. And of course, this is uniform acceleration. And then this is at rest. So the answer is B. Okay? That's your speed time graph.